Right now, Jupiter is still tearing Io apart, volcano by volcano, piece by piece, and NASA has no way to stop it. Scientists are watching it happen in real time, and their models cannot explain what comes next. What Jupiter is doing to its own moons could rewrite everything we thought we knew about how solar systems live and die. But here's what nobody is telling you. Jupiter is the largest world in our solar system. 11 Earths fit across its face. 1,300 Earths could fit inside it. It holds 95 confirmed moons, more than any other planet ever catalogued. And for generations, we looked at that number as proof of its power, its gravitational empire. But new data from NASA's Juno mission, combined with deep archival modeling from teams at the University of California, is forcing researchers to confront something they weren't prepared for. Jupiter isn't just holding those moons, it's eating them. It has been eating them for billions of years. The moons we see today, that vast, crowded family of 95, may be the survivors of a much larger system, a system Jupiter itself dismantled. And Io, the closest Galilean moon, the most volcanically active body in the entire solar system, is next. Here's what Juno found. Io is being ripped open, not metaphorically, literally. Jupiter's tidal forces are so powerful that they squeeze and stretch Io's interior like a rubber ball being wrung out. 400 times more energy than all of Earth's volcanoes combined, released every single day. That energy has to go somewhere. It erupts. More than 400 active volcanoes across a single moon. Lava lakes the size of small countries. Plumes of sulfur dioxide shooting 250 miles into space. And then Jupiter takes it. Its magnetic field sweeps that ejected material into a glowing plasma ring called the Io plasma torus, a structure so dense with stolen matter that it generates its own radiation belt. Jupiter is literally surrounding itself with the remains of a moon it is actively dismantling. And here's where scientists got quiet. The rate of material loss from Io is accelerating, not slowly, not gradually, faster than the models predicted. The obvious answer was tidal heating. Jupiter's gravity does that, we knew that. But tidal heating alone doesn't explain the rate. It doesn't explain why Io is losing mass faster now than it should be at this stage in its orbital life. Researchers at Caltech ran the numbers 3 times. The models keep breaking. And it's not just Io. Jupiter's 4 innermost small moons, Metis, Adrastea, Amalthea, Thebe, are all locked in orbital decay, spiraling inward, slowly falling toward Jupiter millimeter by millimeter, year by year. The same process dissolving Io's surface into a plasma cloud is pulling these smaller moons inward, toward the planet, toward destruction, and no team on Earth has proposed a mechanism that stops it. But here's the strange part. It shouldn't be possible at all, not at this scale, not in this solar system. Jupiter formed 4.5 billion years ago. Its moons formed alongside it in a disk of gas and dust called a circumplanetary disk, basically a miniature version of the entire solar system's formation process playing out around Jupiter alone. Standard models say that disk should have stabilized the moons, locked them in place, protected them. But in 2023, a team at the University of British Columbia reconstructed Jupiter's early moon formation history using new orbital resonance data, and what they found was disturbing. Jupiter has already consumed its first generation of moons entirely, not lost them, consumed them. The inner moons we see now, Io, Europa, Ganymede, Callisto, are the second generation, or possibly the third. The original moons spiraled inward billions of years ago and were swallowed whole. Their mass became part of Jupiter, their orbits erased, gone as if they never existed. And here's the part nobody wants to say out loud: that process never stopped. It slowed, but it never stopped. What we are watching Io experience right now, the volcanic stripping, the plasma bleed, the orbital decay, is the beginning of the same sequence. And Europa, the moon we believe may harbor a liquid ocean beneath miles of ice, is next in line. Think about what that means. Europa, the moon that entire space programs have been redesigned to reach. The moon NASA's Europa Clipper, launched in October 2024, is currently flying toward right now. The moon scientists believe may be the most likely place in our solar system to find life. That moon is caught in the same slow consumption cycle that has already erased entire generations of Jupiter's children from existence. The Clipper arrives at Europa in 2030. It will study the ice. It will search for biosignatures. And the entire time, Jupiter will be doing what it has always done: pulling, tightening. The very tidal forces that make liquid water possible on Europa, the heat, the pressure, the churn that gives life a chance, are the same forces that will eventually destroy it. So here's what keeps researchers awake at night. If Jupiter has already eaten multiple generations of moons, and if Europa is somewhere inside that sequence, how much time does it actually have left? And is what we call a potentially habitable moon just a moon that hasn't been consumed yet? Drop your answer in the comments.